Hello, how's it going? In the previous video in this series, we got skeletal animation. That was really cool. We ran through the process of taking our vertices from mesh space down into local bone space and then transforming them. So this is really cool. We can get some models walking around in the world, but we don't just want our models that we make to be imported. Wouldn't it be great if we could also get those models holding things, put hats on our models, all those sorts of things? Usually this is accomplished with something called sockets. A socket is an abstract representation of the bone's transformation. I'll pop up the video right now. This is what it looks like. We can get our model and we can attach any other OBJ model, like a gun in this case, to the model's hand, head, or anything else. So, how does this work? Well, let's get into it. First of all, we know from our GLTF file that all of our bones have got some info, including a name. So let's go ahead and save that little bit of data in our bone struct. We can see here we have a bone struct and we're just putting in another field, which is the bone's name. Then, as well as storing transformation matrices for each bone, our skeleton is going to store socket matrices. Now, there's a subtle difference between a socket matrix and a transformation matrix, and it's this. This is the basic idea. Let's say that I'm a mesh, and here's my arm right here. The vertices of this arm are defined in mesh space. So my origin is right down there by my feet. If I want to deal with any sort of finger transformations or something, I need to get into the finger's frame of reference. But that's where the inverse bind matrix is used. Let's say, for instance, that we have a mouse. Now, the kid on Fiverr who I paid to model this mouse did not know about the vertex space or where we were going to put this on the model. In other words, the mouse model has its own origin somewhere in relation to it. And actually, we probably don't need to use an inverse bind matrix. We can just position it on the bone, and the mouse's origin will correspond with the bone's origin, and there may be some adjustment needed, but it's more or less going to work. So anyway, yeah, like I was saying, on the skeleton, we're going to need some way to say, hey, if you give me the name of a bone, I can give you the socket transformation associated with it, and that's why I'm using a hash map in this case. So like I was saying a second ago about the inverse bind matrix, socket matrices do not need them. So when we go in and we update our skeleton, we have two stages. The stage with just the standard transformation, including the parent's transformation, and then the second pass where we pre-multiply the inverse bind matrix. Now, right at the end of the first pass for each bone, before we go ahead and pre-multiply the inverse bind matrix, we can go ahead and save the current matrix as the associated socket matrix. Now, as I'm going through this, just a quick note about my source code for this video. It badly needs a refactor. It's sort of software gore. So I'm trying to just give an implementation. This is not necessarily the best implementation. It's just something that works right now. So before we had these game objects, and game objects could have positions, rotations, all of that. What I'm also going to do is give every game object an optional name, which represents a socket that it could be attached to. Then on the renderer side, there are sort of two main stages. There's the stage of updating all the resources on the GPU, all the transformation matrices for the visible objects, and then there's a second stage of actually drawing those objects. So when it comes to drawing those objects, we don't need to make a change. We can keep things as they are, provided we're really careful about the transformation matrix that gets passed through to the model. So like I said, software gore, but in my very constrained implementation, I know that this gun model is going to be attached to the skeleton model, the character. And so what I'll do is fetch the attachment name from the gun, then go into the skeleton, fetch the socket matrix for that attachment name, and then I've got that socket matrix, but I also want to post multiply the character's transformation. Because of course, we've got the gun attaching to the character's hand, that's nice and all, but if the character goes and walks over somewhere else, we want it to follow the character. But otherwise, there we go. We're just putting that in as the model transformation matrix for that OBJ model. When we go and draw that OBJ model, it will all be set up for us. And you can see on the screen, we have our character here, they're holding a gun, and it looks very cool. Anyway, that'll be it for now. I will go and refactor my code, make it look better. I'll see you again soon. Have a good one. Bye. Behind the scenes, Andrew here. I just wanted to give a really big thank you. I hope you enjoyed the video. I'm trying to put a little more effort, make it a little more artistic. If you would like to support the content, if you like what I'm putting out, I've got a Patreon, links are down below. Also got YouTube memberships. And as always, really big thank you. I really appreciate it. What would you like to see next? Drop a comment down below. All right, well, that'll be it for now. Have a good day. Bye.